All right, guys, so we are looking at some exponent problems here that combine the things that we've been learning last week and this week. So the most important thing that you need to know is that an exponent is only simplified, or an exponent problem is only fully simplified when you only have positive exponents left and each base only appears one time. So, in lots of the problems that you're going to be faced with today, you're going to see lots of problems where you have lots of different bases, lots of different exponents, and you have to simplify them before you're able to say that the problem is done. So here, just a reminder that when you multiply like bases, 6 to the 5th times 6 to the 3rd is 6 to the power of 8. You add your exponents, but your base stays the same. And 6 to the power of 6 divided by 6 to the power of 4 is not 1 to the second power. So again, this is not 36. You don't multiply your base. This would be 6 to the power of 8. And here, again, you don't divide the base stays the same. So this would be 6 to the power of 2. So we're going to look at some questions today. And if you really do address these step by step and don't try to take shortcuts or rush, it's super easy. So I'm starting a problem here where I've got two base 3's in the numerator and two base 3's in the denominator. The first thing I want to do is simplify the base 3's in both places. So this is 3 to the 5th times 3 to the 8th. Well, when I multiply like bases, I add the exponents. So this is going to be 3 to the power of 8 plus 5. So that's going to be 3 to the power of 13. Well, now in the denominator, I have 3 to the 6th times 3 to the 8th. So that's going to be 3 to the power of 2 plus 6. So 3 to the power of 8. Well, when I have 3 to the power of 13 being divided by 3 to the power of 8, in order to figure out where the 3 needs to be in my answer, I need to figure out where I have more 3's. Well, I have 13 3's in the numerator and only 8 3's in the denominator, so my 3 stays in the numerator. And 13 is 5 bigger than 8, so this would be 3 to the power of 5. And then this piece here just becomes 1 because it simplified into the top. So when I have 3 to the power of 5 over 1, I don't need to keep that 1 in the denominator because when you divide by 1, you get what you started with. So your final answer here would be 3 to the power of 5. That's a 5. All right, so in this next problem here, it's almost exactly the same. You've got 3 squared times 3 to the 7th in the numerator, so you want to simplify your numerator, and that's going to give you 3 to the power of 9, because 7 plus 2 is 9. And then in the denominator, you have 3 to the power of 0 times 3 squared, and that's going to give you 3 squared, because 0 plus 2 is 2. Well, when I think about where my 3 is going to be in my answer here, I have 3 to the power of 9 in the numerator, 3 squared in the denominator. I know that 9 is bigger than 2, so I keep my 3 in the numerator, and 9 is bigger than 2 by 7, so it's 3 to the power of 7 over 1. Again, when that 1 is in the denominator, you don't need to keep it there, so your final answer is just 3 to the power of 7. So as we continue through these, they're going to be very, very similar. The only thing here is now we're adding in some negatives. So hopefully you watched the video from Monday, and it told you what to do when you have a negative exponent. So anytime you're solving problems that have negative exponents, the first thing you want to do is rewrite the problem. So if I'm looking here, I have 3 to the power of negative 5. Well, I'm going to take that and I'm going to make it positive by putting it in the denominator and making it 3 to the power of positive 5. Well, here, 3 to the power of 8 is already in the numerator, so it just stays here, 3 to the power of 8. 3 to the negative second is negative, and it's in the denominator, so I'm going to flip it to the numerator, and I'm going to get 3 to the power of positive 3 to the 6 is already positive, so you leave it where it is there in the denominator, so that's 3 to the power of 6. Well, now this problem is back to the problems that we just did before. I've got to do 3 to the 8th times 3 squared, and that's going to be 3 to the power of 10. Then I have 3 to the 5th times 3 to the 6th, and that's going to be 3 to the power of 11. So now I can't have a base of 3 in the numerator and the denominator. So I know that I've got 10 3's here, 11 3's down here. So my 3 is going to stay in the denominator there, and 11 is 1 bigger than 10, so it's 3 to the power of 1. Well, now I have my 3 in the denominator, so I have to take that placeholder 1 and it goes in the numerator. Now it matters. I can't just say this is 3 to the power of 1. I have to state that my final answer is 1 over 3 to the power of 1, which is just 3. So my final answer is 1/3. All right, again, this one's going to be very, very similar. Anytime we have negative exponents, we start by rewriting the problem to eliminate the negatives. So 3 squared here is going to stay exactly where it is as 3 squared. Well, 3 to the negative 7th needs to become positive, so I need to take it from the numerator and put it in the denominator to make it 3 to the positive 7th. 3 to the 0 can stay where it is, though 3 to the 0 is actually just equal to positive 1, so it almost doesn't matter at all. But now I'm going to take this 3 to the negative second. I want to make that positive, so I swing it to the top, and I've got 3 to the positive second. So when I go to simplify here, I've got 3 squared times 3 squared, and that's going to be 3 to the power of 4. Then I've got 3 to the 7th times 3 to the power of 0. Well, that's just 3 to the power of 7. So now when I go to simplify, I see that I have more 3's in the denominator. So my 3 stays in the denominator. 7 is 3 bigger than 4 because 7 minus 4 is 3. So I have 3 to the power of 3 in the denominator. I keep my 1 in the numerator as a placeholder. So my final answer is 1 over 3 to the power of 3, which is the same thing as 1 over 27. Remember, if the exponent is 2 or 3, technically it's part of your summer math, so you could continue to evaluate. All right, so in this type of problem, we're actually combining different rules here. And this is where people sort of get a little bit confused sometimes because they get tricked into thinking that this down here is power to a power. So I will encourage you, anytime you want to use the power to a power rule, you want to make sure that you have an exponent right next to an exponent. If you can't like create a circle where they are just immediately next to each other, you should not be multiplying. So here I do have 2 raised to the power of 2. So when I multiply those, that gives me 4 to the power of 4. Well, now I have 4 to the power of 4th multiplied by 4 to the power of 6. Now, these are not right next to each other. I can't draw a nice little circle there and do the multiplication. They're too far apart. That should indicate to you that this is really just 4 to the 4th times 4 to the 6th. And 4 to the 4th times 4 to the 6th is actually 4 to the power of 10. So again, do not be confused into thinking that that's multiplication. That's only when they're right there, right next to each other. So this is 4 to the power of 4 over 4 to the power of 10. Well, I can't have a base of 4 in the numerator and the denominator, and I know that 10 is bigger than 4, so my 4 lives in the denominator. Well, 10 is 6 bigger than 4 because 10 minus 4 is 6. So I end up with 1 over 4 to the power of 6. Now in the next one here, very, very similar. Here you've got your power to a power rule because you've got exponent parentheses exponent right there next to each other. So that's going to be multiplication. So that would be 8 to the power of 2 times 4. So that's 8 to the power of 8. Then here, this is 8 squared times 8. And anytime you have a plain old number there, you want to add the 1. Otherwise, you're going to forget that when you multiply these, this isn't just 8 squared, it's actually 8 to the power of 2 plus 1, so it's 8 to the power of 3. So now if I'm looking here, I've got a base 8 in the numerator and a base 8 in the denominator, so this is going to be, well, 8 is bigger than 3, so my 8 stays in the numerator, and the difference between 8 and 3 is 5. So I get 8 to the power of 5, and in the denominator, I have 1. So that ultimately simplifies to just 8 to the power of 5. All right, so these are the last 3 problems, or there's 4 more here, excuse me, that we're going to look at today. And these look a lot harder, but they're really not any harder. The only difference here is that we have 2 different bases. So when I go to look at this problem here, I see that there are no negatives. So I don't have to start by rewriting anything, but I do want to make sure that I go to this plane 4 and add a 1 there. So now I'm going to simplify in the numerator. And to start that, I'm going to multiply 7 squared by 7 to the 4th. I can't combine the 4s and the 7s, but I can put the 7 pieces together. So that's going to be 7 to the power of 2 plus 4, so that's 7 to the power of 6. Well, I now need to deal with my 4s, so that's 4 to the 3rd times 4 to the 1st, so that's actually 4 to the power of 4. Well, if I look in the denominator here, I have 4 to the power of 4, and that's the only 4 piece, so I can put that in my denominator. And now I look and I combine my 7s in my denominator, so that's 7 to the 6 times 7 squared, so that's going to be 7 to the power of 8. So now I have to simplify here. So I've got a 7 in the numerator and the denominator. I've got a 4 in the numerator and the denominator. So when I go to solve here, my 7 is, well, I have more 7s in the denominator. So my 7 stays in the denominator. And that's 7 to, well, 6 and 8. The difference there is 2. Well, now I look at my 4s. My 4s are exactly the same in the numerator and in the denominator. So when that happens, the pieces cancel out. That's saying 4 to the 4th divided by 4 to the 4th. Well, if you take something and you divide it by itself, you get 1. So it's like it goes away. So now all I have is 7 squared. It's in the denominator, so I know I need a placeholder of a 1 in the numerator there, and my final answer is 1 over 7 squared. Well, 1 over 7 squared is the same thing as 1 over 49, so just be aware it could appear either way there. All right, so we're going to keep going here. Again, we don't have any negatives, so we don't need to start by rewriting, but I'm going to take that 5 and make it 5 to the 1st power. I'm going to start by combining my 5s. So 5 squared times 5 to the 3rd times 5 to the 1st. 2 plus 3 plus 1 is 5 to the power of 6. Then I'm going to deal with my 6 here. So I just have 6 to the power of 4. So that's times 6 to the power of 4. Well, now in my denominator, I want to combine my 6's. So I've got 6 to the power of 4 times 6 to the, or 6 to the power of 6 times 6 to the power of 4. Well, that's 6 to the power of 10. And then finally, 5 squared there is right here. It's all by itself. So now I'm going to simplify. And first thing I want to do is I want to figure out where my 5 lives. Well, I've got more 5s in the numerator than the denominator, so the 5 lives in the numerator there. And the difference between 6 and 2 is 4, so it's 5 to the power of 4th in the numerator. Well, now I need to simplify my 6 here. So 6 to the 4th over 6 to the 10th, so this is going to be 6. There's more 6's in the denominator, and the difference between 10 and 4 is 6, so that would be 6 to the power of 6. So that right there would be our final answer. Now, these next problems look harder, but they are not any harder. The only difference here is that when I look at this, I start observing that I have negative exponents. So when I solve a problem that contains negative exponents, I want to rewrite it before I start. So basically, I'm going to take every term and either keep it where it is or flip it. So 7 squared is already positive, and it's already in the numerator, so it stays in the numerator. 4 to the negative 3rd is in the numerator, but it's negative, so I switch it to the denominator, and I make it positive. 7 to the 4th is already positive, so it stays in the numerator where it is. And then the 4 is already positive, so it stays in the numerator, but we remember to make it 4 to the power of 1. Now, 7 to the 6th stays where it is because it's already positive. 4 to the negative 4th flips up to the numerator because we need to make it positive, so it becomes 4 to the positive 4th. And 7 squared should stay where it is because it's already positive. I started with 1, 2, 3, 4, 5, 6, 7 pieces. I still have 1, 2, 3, 4, 5, 6, 7 pieces. Now they're just all positive. So at this point, the process continues just like the problems that we just did. I've got 7 squared times 7 to the 4th, and that gives you 7 to the 6th. Then I've got 4 to the first times 4 to the fourth, and that's going to give us 4 to the fifth. Well, now I'm going to keep using my 4 colors, so I've got 4 to the third. That's the only thing down there that I can do with the 4. And then my 7 is 7 to the 6 plus 7 to the 6 times 7 squared, so that's 7 to the 8th. So now when I go to look at this, I know that I've got a base of 7 in each place, so I have to simplify. Well, the 7 is bigger and the 8's bigger, so I've got 7 here, and 8 minus 6 is 2, so it's 7 squared in the denominator. Then here I have 4 to the 5th and 4 to the 3rd, so that's going to be 4 squared here, because that is 2 bigger than 3. So here, this could be your final answer, 4 squared over 7 squared, but 4 squared is the same thing as 16, and 7 squared is the same thing as 49, so that is another possible answer. All right, so here we go. This is our final problem, and then I'm going to show you one little thing, and then you're good to go for today. So again, in this one, we've got some negatives, so we have to start by rewriting the problem. So 2 squared is already positive, stays right where it is, 2 squared. 9 to the negative 8th has to switch to the denominator to become positive, so it becomes 9 to the positive 8th. Well, here, 9 to the 4th is already positive, stays where it is. 2 to the 6th, already positive, stays where it is. 9 to the 6th, already positive, stays where it is in the denominator. But 2 to the negative 4 has to go to the numerator and become 2 to the positive 4th. And 9 to the negative 2nd needs to go to the numerator and become 9 to the positive 2nd. So now I continue by combining my like terms here. So I've got 2 squared times 2 to the 6th times 2 to the 4th, so we just add. 4 plus 6 is 10, plus 2 is 12, so that gives us 2 to the power of 12. Well, and now we deal with our 9s, so this is going to be 9 to the power of 4 times 9 to the power of 2, so that's going to be 9 to the power of 6. Well, I look in the denominator, only thing to combine is my 9s, so that's going to be 9 to the power of 8 plus 6, which is 14. So when I look at my answers here, there's only one piece that I can simplify. My 2 to the 12th needs to stay exactly where it is, and it can't be simplified, so it just stays right there in the numerator as 2 to the 12th. Now here you have 9 to the 6th over 9 to the 14th. Well, the 14 is bigger, so your 9 stays in the denominator and becomes 9 to the power of 14 minus 6, which is 8. So that right there would be your final answer. So again, it doesn't have to be the case that you have one term in the numerator in your answer and one term in the denominator. Sometimes they're both in the numerator, sometimes they're both in the denominator. So in this question right here, we have our 3's. So if I deal with my 3's, I've got 2 and 10. 10 is bigger, so my 3 stays in the denominator. And 10 minus 2 is 8, so I'd have 3 to the 8th in the denominator here. Well, now I'd go deal with my 5's, and the 9 is bigger than the 4, and that's also in the denominator. So my 5 would stay here in the denominator, and 9 minus 4 is 5. So I would have 5 to the 8th times 5 squared, all in the denominator. Now, because both of the terms are in the denominator, you need a placeholder here, and so you would have a 1 in the numerator, and that would be your final answer. So again, whether or not the pieces are in the numerator or the denominator at the end is all about where the power is bigger on the base. So it's possible that they're both in the numerator. It's possible that they're both in the denominator. It's possible one of each. You have to pay attention to which piece, which exponent is bigger, the one in the numerator or the one in the denominator. I hope that helps. What you have just done is you have just watched this video, which it didn't say this, it said video about this, so you just watched that. Hopefully you've already done the Monday work. All you have to do tomorrow is, or on Wednesday, is this little 8-question skill check. On Thursday, you have a little video that goes over more questions that look more questions kind of like these ones at the end. So it's not really new, but it goes more deeply into these type of questions to give you more practice. And then you have a little 6-question check-in on Friday. So again, this week is not that much. Please do it and do it well. As always, I am here for you, so you just reach out if you need me. All right, bye.